Okay, so 6.4, number 18 here, it says two friends can paddle a canoe at a rate of 6 kilometers per hour in still water. Okay, so we got a bit of a canoe here. We got two friends that are paddling. Okay, here we go. I'm going to draw a picture in this, of course. Going to need to do that. There's a paddle. And there's another set of friends there. Another guy there, or a girl, whatever. Paddle in the water. Awesome. Awesome. So it takes them 1 hour to paddle 2 kilometers up the river and back again. Okay. So going up the river and down the river, the total time is 2 hours. 1 hour?
That's what I'm confused about.
But
I
the
don't understand.
1 hour to paddle 2 kilometers up the river and back in. So it's 1 hour for 2 kilometers.
Yeah, but is it 2 kilometers up?
Okay. Okay. So find the speed of the current. So that means that there is a current speed. So in still water, they can do this. But they're either going to be facing a current on the way up or they're going to be facing a current on the way back. So think about it. If they're facing a current on the way up, it's going to take them, they're going to go slower. Okay, so they're going to go pretty slow if they're facing a current. On the way back, they're going to go pretty fast. See that? So you don't really know. You can't assume that the extra time it takes them to go against the current equals the time they save going with the current. Can't really assume that. So instead, we kind of got to figure out. It might take them much longer to get up against the current if it's really strong, and then it'll take them much faster. So it might not always be kind of a one-to-one thing. Okay, so we're trying to find the speed. Okay, so we're trying to find the speed of the current. Okay, so we've got speed of the canoe, right? We know what that is generally, 6 kilometers per hour. Speed is built from what? Distance over time. Okay, so distance over time. So so what we need to do is we need to figure out the speed going up is going to be speed 1, and the speed coming back is going to be speed 2. The speed of the current. How can we let the speed of the current be x or a variable? How can we do that? How can we let the speed of the current be a variable? Any ideas? So if let's say we're going against the current, okay, so these guys can do 6 kilometers per hour, but if the currents are going against them, it's going to be minus this opposing current. So that's going to be their speed 1, let's say. Okay? So again, we're going to write a whole bunch of things down. We're going to try and piece it together in the end. Speed 2, going with the current, is going to be what? 6 plus x. Right. It's going to be their speed in quiet water or still water, and then added to the speed of the current because they're going with the current. Okay. So those are speeds now. Okay. And I've got the speed of the current as x in here. Nice. Okay, how can I tile this? How can I tile this together? Well, speed is distance over time, right? We're given a time and a distance. So it's the total trip is it says 1 hour. So 1 hour and 2 kilometers. So 2 kilometers in 1 hour. That's the total, right? It takes them. So the total speed, I see this as a total speed here. So I wonder if I could figure out how to add up speed 1 and speed 2, or to somehow average them or whatever to get the overall average speed. How can we do that? Could we do 6 minus x plus 6 plus x? Would that work? No, that wouldn't work because then we'd have just 12 equals 2. That doesn't work. Okay. Could we add up to a distance? How could we add up to a distance of 2 kilometers? What is distance? Well, distance is speed times time, right? That's what distance is. Speed times time. Okay. So if I've got speed 1 is 6 minus x, what's the time It's not half an hour, because we can't assume that it takes half the time to get there and half the time to get back, because that's the whole point here. We've got varying speeds. So the time is going to be different. So 6 minus x is the speed on the way up there, and 6 plus x is the speed on the way back. So I'd need to find out, what kind of time I would have to put in there, and then I could add those maybe. So we're getting closer. All right. So we just noticed something here, that this 2 kilometers here, we're assuming that the whole trip is 2 kilometers, but when we read this again, I think that it's 2 kilometers there and 2 kilometers back again. So that means this is going to be 4 kilometers. Okay. And it takes 1 hour. So if we've got time here, we're going to have to introduce another variable, t, and then 1 minus t. I'm not sure if we like that. I don't know if that's a good idea. Why is that not a good idea? Because we had too many variables there. Okay, so if we're working with distance, I think we're going to be in trouble, because we don't know the speed, but we also don't know the separate times. So let's think about something different. If you tried that, you might run into a bit of problems. But let's talk about time, because we do have the total time is 1 hour. So let's talk about time now. Equals 1 hour. So how do I get time from speed and distance? And knowing that here it's a 2 kilometers one way. So where's my time? Okay, so time equals distance over speed. You see that? So we might be onto something here. So the distance is going to be 2 kilometers on the way up there, divided by the speed 1 would be 6 minus x. And we could add to that 2 kilometers again over 6 plus x. And I think that's what we're going to have to do, because that just gives us one variable. Okay. All right. So yeah, I think this is the way that you want to do this then, knowing that the 2 kilometers is just a one way, which that was confusing to me as well. So, okay, so now how do we solve for this? Well, we multiply both sides, or everything, by 6 plus x and 6 minus x. So that's going to give us 2 times, well, the minus x's are going to go, the 6 minus x's are going to go, so it's going to be 2 times 6 plus x here, plus 2 times 6 minus x here, equals, now this is just both of them times 1, so 6 plus x times 6 minus x. Okay, so we got one variable, we got one equation. I think we got everything straight in here now. That's great. So let's expand. 12 minus 2x equals 36 minus x squared. That's going to be a difference of squares there. All right. So 12 and 12 is going to be 24 plus, oh, those x's are gone, looks like. Is that right? Yep. So 24, I'm going to subtract the 36 from both sides. Let's do a couple steps at once. Gives me a negative x squared. So what's that going to be? Is it 12? Negative 12 equals negative x squared. So that's going to be positive 12 equals positive x squared when I divide both sides by 1. And x should equal, let's see, plus or minus root 12. Now, as far as an x goes, okay, should I take the positive one or the negative one, or should I consider both? Well, I mean, yeah, you usually want to stay away from negative stuff in questions like this, right? I mean, yeah, because you're adding a negative and adding, or subtracting a negative and adding a negative over here, and then you're subtracting a positive and adding a positive over here. It works out to be the same thing. But we'll just take a look at the principal square root here, which is positive root 12. So if that's the case, then it looks like the current, which we set to x, and I just solved for x, it looks like the current might be positive root 12. Or, I mean, positive or negative, the current would be whatever decimal this is. So we'll have to double check that. But okay, so that x is about 3.46 or 3.5. That would be kilometers per hour. So that is that's the speed of the current. So what can we learn from this other than that's a bit of a tricky question? Well, if the question asks you to find the speed of the current, try your very best to make that the unknown variable. Okay? And then try and fit that variable into an equation given all the information. So you want to read the question carefully. I think I understood this to be 2 kilometers in total distance, but upon closer inspection, that appeared to be 2 kilometers one way. So if you did 2 kilometers in total distance, you would have, gotten a different answer there. I'm not sure if anybody did that and got a different answer. Yeah, maybe.
No, I messed up.
Okay. So this one here, what else can we learn? This right here, if you have 2 variables and you can't really reconcile that, that's not good. You want an equation with 1 variable only if you can. So that's why we changed from working with distances to times. And speed, we tried speed too, right? That didn't work either. 6 minus x plus 6 plus x, right, equals x. That just comes up to x equals x. So that's not good. Or actually 6 equals x. Well, I don't know. That doesn't work. It doesn't work at all. Because we're not including the time or the distance at all in there. So you have to include those parameters as well.